our final project, which is entitled Enhancing Students' Learning, an interactive ebook-based flipped collaborative learning approach for STEAM courses. The group members are Khan, Hosni, and Bex. So in this presentation, we will focus on introduction, literature review, multimedia design, and research method. Introduction. The future economic growth and innovation relies on STEM. Yet the number of students pursuing study in this area is decreasing. Again, the professionals in this area is also decreasing. That is a problem. So in order to overcome this problem, teachers started to introduce different multimedia, including interactive textbook in teaching STEAM courses. And it improved the students' grade in United States of America universities. Nowadays, the emergence of STEAM education, an interdisciplinary approach that focuses on critical thinking, creativity, and problem solving is occurring worldwide. So here we integrated A. So integrating multimedia into STEAM learning is a hot issue. Just to increase the number of students who are joining STEAM education. So a situation-based interactive ebook approach improved children's performance in learning numerical operations. When we combine interactive ebook-based with flipped learning, this had positive effect on students' learning performance and self-efficacy in learning elementary school mathematics. It's known that flipped classroom is an active learning, which makes the learners to be more interactive in learning activities, and they will collaborate with each other to discuss the lesson after watching the video outside the classroom. So we have the following rationale to conduct this research. The first one is those literatures, the existing literatures mainly focused on the effect of interactive ebook on the performance and self-efficacy, but not problem-solving skill, engagement, and cognitive load. This is the first rationale. The next one is collaborative learning can be used in every level of studies, but it is widely used in higher institutions. There is a lack of research in using flipped collaborative learning in primary schools. The third rationale is just to expand literature on interactive ebook-based flipped collaborative learning in STEAM courses. So these are the rationale to conduct this study. So we want to answer the following research questions. The first one is, can the interactive ebook-based flipped collaborative learning approach enhance students' learning outcomes compared to conventional video-based flipped collaborative learning? Second, can the interactive ebook-based flipped collaborative learning approach enhance students' problem-solving skills compared to the conventional video-based flipped collaborative learning? Third, can the interactive ebook-based flipped collaborative learning approach enhance students' engagement compared to conventional video-based flipped collaborative learning? And the last one is, can the interactive ebook-based flipped collaborative learning approach lower students' cognitive load compared to the conventional video based flipped collaborative learning. Literature review. Interactive ebook. Interactive ebook are digital learning materials implemented in such an interactive multimedia mode on tablet computers, smartphones, or personal computers, and it has the potential to change the way our students read and consume text because of their interactivity and convenience. Using interactive ebook has positive effect on students' learning performance and learning motivation. Main focus of interactive ebook learning based study were related with language learning, particularly emerging literacy, vocabulary reading, and maths, emergent math. However, less attention was given to STEAM course in primary level. So early exposure to STEAM-related concepts is critical to later academic achievement. Flipped collaborative learning. Flipped classroom refers to engaging students in gaining basic knowledge before class and provide more activities such as doing exercise or interacting with peers and the teachers in class. Collaborative learning is an instructional method where a group of learners work collaboratively or together within a class and out of class to achieve common objectives and goals. Collaborative learning can be applied in every level of studies, but it has widely applied as an instructional method in higher education because adult learners tend to study based on their previous knowledge, experience, and according to their convenient time and place. To combine flipped learning with out-of-class collaborative learning, a number of technology can be used, such as discussion forum, video, social media, and chat room that allow the learners to share and work together to solve the problem together through virtual world. However, there is lack of research in using flipped collaborative learning in primary school.
Okay, the next we talk about learning outcome. Cognitive outcome are divided into conceptual knowledge and technical skill. Yes, based from the Estepa and Naudinly, and also a set of taxonomy include cognitive, affective, and psychomotor domain developed by Benjamin Bloom in 1956. This one we have three first level. For the first is remembering, understanding, and also applying. For the three part of taxonomy Bloom, this one the picture. And the next about the problem solving skill. Problem solving skill comprise a series of mental, emotional, and behavior effort that individual exhibition in order to find an effective way to cope with a problematic and stressful situation confronted in professional and everyday life. And also, according to Kroner et al. 2005 model, we have three sub for the process. For the first is role identification, and the second role knowledge, and the third is role application. This is the role of problem solving skill. For the first is talk about the role identification, describe a target, a systematic application of a strategy to identify the relevant factor and their relationship. And the second, role knowledge, describe the use of this knowledge for predicting certain state of the system. And the third is role application, emphasized the ability to transfer the problem solving competence to a new situation, and as a result ultimately represent its complete execution. And the next is engagement. Yes, we divided here with three engagement. For the first, cognitive engagement, the second, behavior engagement, and the last is emotional engagement. Okay, how about the cognitive engagement? The learner mental investment in the learning, effortful strategy use, and deep thinking and commitment to academic work mediate the way in which value and need rate related to learning and achievement. And how about the behavior engagement? Active participants in both the school and academic activity, as demonstrated through attention, persisting, and asking the answering question. And the next is about emotional engagement, learner effective reaction to others, and connected connection with the social community. This is based on the Frederick 2000, et al. 2004. And the next is cognitive loads. Yes, we have a cognitive load theory, and the second is like cognitive theory of the multimedia learning. When we talk about the cognitive load theory, yes, it's limited capacity of the working memory in terms of the amount of information that can be processed simultaneously and amount of time information is maintained for the processing. Yes, we have three elements here. The first intrinsics, the second externals, and the third is Germans. And how about the cognitive theory of learning, multimedia learning? Is based on the view of active knowledge constructs. We have three steps here. The first is selection, and the second is organizing, and the last is integrating. And okay, the next is talk about the multimedia design. Here we have an interactive ebook. The first is pre-designing stage, and the second is designing stage, and the third is like implementation stage. For the pre-design stage, we have a choose topic, brainstorm the context of ebook, and then design appropriate tool. And for the design stage, create interactive ebook use Kotobi, and then pilot testing a ebook. And the third implementation stage gives student interactive ebook and ask student to do flip learning. Okay, the next is design of interactive ebook. The first is introduction, and the second is content. The second picture is content, and the third is exercise. How the student exercise after learning about the content in the ebook in Katabi here. And this is the collaborative learning. We have a catalog, search, sharing notes, next page, and previous is part of the interactive function to make the ebook more interactive to student. This one can engage student to uh, active and collaborate with other his peer and for the another student in the collaboration learning. And this is the collaborative learning. Here we have how many the group that we create in the class. This is the example for the group. We have three group here. And then how about the class? You use the class dojo and to demonstrate the class and help student to make easy in our activity in the class. And this one, the collaborative learning, we have like activity and how about the student and what is the interactive here, that what's the point of our learning in the interactive ebook with the robotic. This one in how about the active learning, and how about the student can, yes, ask the student, can you tell us how many parts there are in a robot, and the next like which part the control and which part the robot, and also how about this component is in individual component in the robot, and also another is like the next is like which part connect between the body of robot and remote and etc. How many questions here. And also active assign it to student, divide what's the next and learn. And how about the student activity here? It's more collaborative and more interactive to make student in engagement in the learning process.
Next part I want to introduce is about research method. So I want to introduce about the design and sampling. So in this study, we use the quasi-experimental study. There are 66 graded students, including 35 boys and 25 girls in an elementary school in Taipei participating in this study. And based on the river score, the students are classified into 3 levels: high, middle, and low achievers. There are 30 students in the experimental group, while control group has 30 students. And these students had the same learning content and they taught by the same teacher. However, there is one difference between two groups. The experimental group, they will experience the interactive ebook-based flipped collaborative learning, while the control group, they experience the video-based flipped collaborative learning. So in the experimental group, before the class, the student will experience the interactive ebook, and then they will follow some collaborative activity in Class Dojo. As you can see, the student will have some activity based on the interactive ebook, and then the student will follow some activity in the Class Dojo. So in the class, the student will follow some STEAM activities such as assembling, robots, drawing. For the control group, before the class, the student will watch the given videos, and then the student will follow some collaborative activity. And you can see on the left side, there's the videos about robots. The student will watch before the class and follow some activity. In the class, the students also have the same activity like the experimental group. They will assemble the robot and draw. So in this study, we will investigate the student performance on STEAM, including science, technology, engineering, arts, and mathematics. So in terms of science, we will investigate the student knowledge construction related to concept of robotics. Regarding to technology, we will investigate the student technological skills and collaborative live learnings. In terms of engineering, we will assess the student, how they assemble the different components of the robot. And regarding to art, we will investigate the student drawing the components of the robots. In mathematics, we will check the geometry through the student drawing. And this is some activity in the class. The student assemble the robot and they will control the robot. Regarding to the instruments, we use 4 instruments including learning outcomes, problem solving, questionnaire, engagement questionnaire, and the last one, cognitive load questionnaire. So in learning outcomes, there are 2 tests. The first one, retest and post-test, and 2 tests with 20 multiple choice questions. So for the retest, we will investigate the students' equivalent basis of knowledge of 2 groups. And for the post-test, we will assess the student understanding of the robotic. The tests were designed by 3 experienced teachers. And this is the example of the test. You can see we will investigate the post-test related to the Bloom taxonomy related to remembering, understanding, applying. For example, we will have some question like what is this and what is the function of this protein. The second one, problem solving questionnaire, has 6 items and it follows 5-point Likert scale. This questionnaire was developed by Lai Huang 2014 with High Cronbach Alpha. And this is the example of problem solving questionnaire. For example, I believe that I can have the ability to solve the problem I encounter, or I believe that I can solve problems by my own. The next questionnaire is engagement with 25 items, followed with 5 points like a scale. In this questionnaire, there are 3 aspects: behavioral engagement, cognitive engagement, and emotional engagement. You can see for behavioral engagement, there's one example like I listen carefully to everything that is said in class, or ask questions about what I do not know. In terms of cognitive engagement with 7 items, like I always ask the instructor about difficult content, or emotional engagement, I enjoy the class. This questionnaire was developed by the River Study 2014 with the High Cronbach and Farr. And the last one, cognitive law questionnaire with 8 items, follows this board like a scale. In this questionnaire, there are 2 parts, mental load with 5 items and mental effort with 3 items. This is example you can see. So for the mental load, the example, the learning content in this learning activities were difficult for me. And for the mental effort, during the learning activity, the way of instruction of or learning content presentations cost me a lot of mental effort. And this questionnaire were adapted by Huang Yang and Guang 2013 with the High Cronbach and Farr. The next one is rubric to check the student performance, and this rubric will be modified from the Canvas 2020. So in this study, we will investigate 5 aspects, including science, technology, engineering, and mathematics. And there are 4 levels in this study: beginning, developing, proficiency, and explanatory. For example, for the beginning, in terms of science, we will check the student knowledge related to the robotics. And if the student have the minimal knowledge, so we can give 1 point. And if the student have some basic information related to the robotics, we can give 2 points. About the previous procedure, as we mentioned before, the students were assigned into 2 groups, experimental group and control group. So at the beginning of the course, we will give the student the pre-test on learning outcomes, pre-questionnaire on problem-solving skill, engagement, and cognitive load during 45 minutes. And then the teacher will introduce the basic knowledge during 20 minutes. And in the experimental group, we will use the interactive ebook-based live collaborative learning. And in the control group, the student will use the video-based live collaborative learning. In the class, the student will follow some STEAM activity related to the robotics. And this experiment will be conducted during 5 weeks and 30 and 70 minutes for each week. After 5 weeks, we will give the student post-test on learning outcomes, post-questionnaire on problem-solving skill, engagement, and cognitive load. About the data analysis, we will use quantitative approach to analyze the data. So in this study, we will investigate 4 aspects: learning outcomes, problem-solving skill, engagement, and cognitive load. So to investigate the differences between pre-test and post-test, we will use the pair sample t-test. And the second one, we will use two-way ANCOVA with pre-test as covariate. And we will investigate the interaction effect between the design, experiment, control with the level of the student, low, medium, and high achievers. And based on the control, based on the result, we will come to the final result, final conclusion. And these are some references we use in this study. And that is the end of our study. Thank you so much.